Hello friends, let us solve some more problems on bearing capacity. Read the given problem. Using Tarjagi theory, determine the ultimate bearing capacity of continuous footing 2 meter wide resting on saturated clay. So what is the type of the soil? Saturated clay. What is the type of the footing? Continuous footing. That means no multiplication of the shape factors. Width is given as how much? 2 meter. Depth is given as how much? 3 meter. Okay. The water table is at a depth of 3 meter from ground level. Let us say 3 meters from ground level. Okay. After that, what has happened? If the water table rises to 1 meter, calculate the percentage reduction in bearing capacity. So what is the given data here? That means consider a footing. Let us assume this is ground surface. So what is the data given? The width is nothing but a 2 meter and depth is given it as 3 meter. Where is your water table? So if you read the problem, the water table is 3 meter from the ground level. That means what is 3 meter means it is at the level of foundation. So this is in the first case. What happens in the second case? If water table rises to 1 meter, that means in the second case, your water table may be somewhere here. So what is the distance from here to here? It is 1 meter. So if your water table rises to 1 meter, we have to find out what is the reduction in the ultimate bearing capacity. So how we have to find out it? What is the reduction? Now we'll find out the percentage in reduction. That means if your water table is at a 3 meter, for that case you have to find out bearing capacity. Similarly, if 1 meter rises, so for that case also you have to find out the bearing capacity and then you have to calculate the percentage. So if you see in the problem, what is the type of the soil given? Clay. And what is the type of the footing given? Continuous. So is there any need to multiply the shape factors? No. If it is a clay, what are the values? NC will be equal to 5.7, NQ will be equal to 1, N gamma will be equal to 0. That means the last term will goes to 0. Then what about the ultimate bearing capacity? That will be equal to C into NC plus gamma into D. Now see, in the first case, if your water table is at the ground level, let us say that is your first case. So I am saying it as a case 1, water table 3 meter below, let us say ground surface, I am simply writing it as GS. So find out the ultimate bearing capacity. Is there an effect in the depth term? No. Why? Because as it is at the level of foundation level, it won't affect any ground level. So everything is under dry condition. What is the C value given? 50. And C value is how much? 5.7. What about the gamma value is given? 20. What about the depth? If you solve this, you are getting it as 345 kilonewton per meter square. Now consider one more case, that is if water table is rises to 1 meter. So let us consider that is a case 2. If water table rises to 1 meter, if water table level rises to 1 meter, that means what is happening? In the footing, some part is under submerged condition and some part is under dry condition. Let us say if your water table is here, from here to here, your soil is under submerged condition, but from here to here it is under dry condition. So to find out the ultimate bearing capacity, QUB, that will be equal to, let us say, dash. Again, C into NC, C is how much? 50, NC is how much? 5.7 plus. So here we have to consider two different cases. In dry condition, what is the unit weight? 20 into what about the depth? Total is 3. 3 minus 1, here it is 2. So 20 into 2. plus what is the submerged unit weight? Saturated is given as 25. That means 25 minus 9.81 into how much? 1. So if you solve this, you are getting around 335.5 kilonewton per meter square. This is the bearing capacity if your water table rises to 1 more meter. But what we have to find? We have to find out the percentage reduction. How we'll find out the percentage reduction? That will be equal to change divided by total. What is the change? In the first case, what is the value? QUB. In the second case, Q dash UB. And with respect to the first case, you have to find out. Always remember QUB. In the first case, what is the value? 345 minus second case 335.32 divided by 345. As we have to find out the percentage, multiply by the 100. Multiply by the 100. So the percentage reduction, you will get it as a 2.78%. 2.78% reduction in bearing capacity if water table rises 1 meter. Okay, understood? Thank you.